All right, so in the second lecture, we're going to talk about why Java. And we're also going to talk about object-oriented programming and what it is and why it came about. So let's first talk about Java and why Java is such a robust language. In the early days of programming, what happens when you write a program is that the program is written for a specific platform. Every single machine has a machine language, a language that it understands. And that language is based upon the platform, the processor that the machine is using. And every processor has its own, or should I say every family of processor has its own machine language that it understands. And so if I write a software program and I compile it or convert it from a language that I can speak in my programming language into a language that my machine understands, it is converting it into that machine language, which means that whatever the machine language that my processor is speaking is the language that it's converted into. But what happens if I create a program and I give it to somebody else and they try to compile it or run it on their machine that is speaking a different machine language? It would be the idea of me being in a room with a Spanish-speaking or an Italian or a French-speaking person. We would not be able to communicate. And so that's the reason why when you buy a software, some software, you go into Best Buy, you flip the box over, and it tells you the system requirements in order for the software to be able to run. Because programs are written for a certain platform or a family of processors. And with the advent of the Internet, we needed software that would be able to run across a bunch of different platforms, to be platform independent. And so some people thought up the idea of Java. And the way Java works is that Java is, you write the code and it is compiled into what could be considered bytecode or an intermediary language. And then what I need is an interpreter who can interpret that intermediary language or that bytecode into something that my computer, my platform, can understand, into its own machine language. So imagine if I go to France and I take a French interpreter with me. So I can speak English and then the interpreter listens to what I say and then turns to the waitress or the cashier and speaks in French, interprets my words into the language that the cashier understands. That's exactly what Java came up with. We need an intermediary. So I can compile my language, my program code, down into an intermediary, and then there will be an interpreter on the other person's computer that can take the bytecode that I created and convert it into a language that that person's machine can understand. And that's the brilliance of Java. They created what is called a Java virtual machine, which is in theory an interpreter that is placed on the other person's machine. And the last time I checked, about 98% or billions and billions of people had this JVM, this Java virtual machine, on their computers. As a matter of fact, you may not even know that you know or realize that you have it on your machine. I'm sure every once in a while, every couple of weeks or once a month, your computer will flash a message that says your Java needs to be updated. That's because you have a JVM on your machine. And it is an interpreter that's just waiting for some Java bytecode so that it can convert it or interpret it down into a language that your specific machine, your specific platform can understand. And you most definitely have it on your machine if you do any kind of browsing of the Internet or looking at files or running files off the Internet. This JVM or Java virtual machine is on millions and billions of machines worldwide. And that is the reason why I can create some software on my machine, convert it or compile it down into this intermediary bytecode, and then give it to you, and then the interpreter on your machine converts it into a language that your platform, your machine can understand. So that is the idea of why Java has become so flexible and why Java is the language that the Internet, that most or many of the programs on the Internet are written in. All right, so the second thing that we want to talk about in this lecture is object-oriented programming or object-oriented design. Originally, software programmers would write a series of instructions, and so let's look on the page. There is some kind of a, let me see if I can draw on this page here. There's some kind of defined start point for a program right here. This is where it starts. And then there's instruction after instruction after instruction is run down to some defined end to a program. Now that doesn't mean there's not a few lines of code or a bunch of lines of code over here. And at some point during the program, I'll jump over here and run some code, and then I'll come back. And then I'll continue marching down until I reach some other point. Maybe I go back and run the instructions again, and then come back to my point, down to a defined end. And this is the way programming worked from the very beginning, a procedural, structural sort of flow to the program. And people said to themselves, programmers said to themselves, as programming became more and more prolific, we need to be able to model real-world systems. It's no longer just very simple programs doing this or that. We need very complex programs, and the world is a very complex place. So what we need to do is have a programming language that will model the complexity of real-life systems. And so let's take, for instance, that you're approached by a company to develop a software program for, let's say, a university. And if I look at a university, what I want to do is I realize in a real-world environment that a university system is made up of a number of objects, which I will probably call entities. So if I try to identify objects that make up this university system, the first one that comes to my mind right offhand as a part of a university system would be a student. Oops, spell it right. So students, there are obviously students in a university system. If there's students, there have to be faculty. There are probably some buildings. If there are students and faculty, the one I forgot about is courses, because what is a university system if it doesn't have courses in it? These could be considered objects, entities that make up a university software system, entities. And what I want to do when somebody approaches me to develop software, I want to see if I can identify as many of these entities that make up the system. There would be many, many more, but this is just an example of 4 of them. So I have entities. Every system, did I spell that right? I-E-S. Every system is made up of entities. And each one of these entities have what is called attributes. Attributes are broken up into 2 parts. So let's come down here, and let's see if we can define some of the attributes. So I'm going to come back here. Now let's see if we can see some attributes. Let's take the student. Attributes are broken up into 2 parts. Student. Things that I want to know about a student and things that a student can do. I'll even write attributes. Pardon me for my chicken scratch. It's hard to write with a stylus. So, attributes. The first type of an attribute is know. What do I want to know about a single student? I can't think of a whole student body, but one single student. What are some things that I might want to know about a single student? Well, I'm probably going to want to know what their name is. I'm probably going to want to know what their W number is so I can uniquely identify them. Probably want to know their address so I can send a mail. I probably want to know their class standing. Oops. Their GPA. Did I drop my drama? Their GPA, their class standing. These are things that I'm going to want to know about a single student. So the first attribute is things that we want to know about an entity. The second attribute is the things that a student can do, actions they can take, generally expressed by verbs. Well, students can pay tuition. You're probably very familiar with that. Students can also register for courses. Students can probably graduate, which is what you're going to do soon. You're going to be graduating. So these are things that students can do. Now, each of the entities that identify as a part of a software system, each entity is going to have attributes. Attributes, things that they know, and things that they can do. So, the second part of an object-oriented system are attributes, entities and attributes. And the third thing, the third part of an object-oriented system are relationships. So I'm going to come back down here for just a minute, and I'm going to identify the 4, we found 4 entities: students, faculty, buildings, and courses. How are these different entities related to one another? And a part of an object-oriented system would say entities have relationships with one another. So let's look at the entities called a student and a faculty. How is a student and a single faculty related? I would draw a line between the two, and I would say, well, actually, excuse me, I should have drawn it the other way. A faculty, it makes more sense if I draw it the other way, and a student. There we go. That's much better. So a faculty, let's say, for instance, teaches a student. Well, how about a student, the relationship between a student and a course? Well, a student takes a course. A student registers for a course. A student enrolls in a course. Whatever that word is that you want to say, there is a relationship between a student and a course. But what about a faculty and a course? You can already tell that the relationship between a faculty and a single course would be that a faculty, might use the word teaches again. And one faculty teaches one course. There is a relationship between entities. That doesn't mean that every entity is related to every other entity. It just means that there are relationships between them. If you find one entity that is not related to anyone, there's a very good chance that he is not or should not be a part of your software system. Let's say, for instance, if you'll notice I had buildings on here. There's a relationship between courses and buildings because courses are offered in buildings. Faculties teach in buildings. Students take classes in buildings. But let's say, for instance, I identified an entity called, the gas station down the corner. Well, that has no relationship within the scope of my system. It has no relationship, so it probably is an entity that does not need to be defined as a part of my system. So that is the nature of object-oriented systems. And people said we need a programming language that is robust enough to be able to define these entities and their attributes and the relationships that they have among themselves. Because our traditional programming languages like C, we're not robust enough to be able to represent these sort of objects and this object-oriented programming. So languages were expanded. So we went from C to C++. C++ is the object-oriented expansion of the language C. Java also comes from C. Java is an object-oriented language. That doesn't mean that I can't write these structured sort of programs right here from some defined start to some defined end using languages such as C++ and Java. We're going to find out that we can. It just means that they have the capability to be more robust and express these object-oriented systems. Now, during the course of 1400, we are pretty much going to stay with this structured sort of approach. And if we have time at the very end of the class, I might introduce you a little bit to how Java can express this object-oriented system. But for the most part, we're going to stay here. So let's look at your homework assignment. I'm going to pause this recording for just a minute so I can open up your first homework assignment in Canvas. All right, so I have Canvas open, and you're going to notice there's an assignment called Chapter 1 Case Problem. Now, I've already told you the assignment that I expect you to have done by the close of class or the end of class today, and that is the introduction. Now, you'll have the rest of the evening to send your email to the first semester students or to me if you are a first semester student. But this case problem will be the first homework assignment that you have. Now, you'll notice when you went through the tentative schedule that there are a series of assignments, and then there are also a separate series of case problems. Many times when we're working through assignments in a programming class, people say, oh, this doesn't apply to the real world because it's kind of made up. And so what I've done is I've created 3 real-world scenarios. They could be real-world problems or systems that somebody would need you to write a software program for. And I've identified the 3 separate case problems, as I call them, here in this homework assignment. The first one is called Cost is No Object. The second one is Classic Reunions. And the third is Barking Lot. Your homework assignment for this Chapter 1 case problem is going to review through the 3 different case problems and pick your first favorite and your second favorite. And you're going to submit this assignment telling me what are your top 2 choices for your case problem. Whichever one you are assigned to, you will be in that case problem for the rest of the semester. So whenever a case problem is assigned, let's say in Chapter 5 or Chapter 6, you will be using this case problem that you have chosen to apply the topics that we learned during that particular week. So you're going to want to review the 3, and you're going to want to tell me which ones, the first 2, that you would like to be a part of. Now, it's on a first-come, first-served basis because I'm only going to have a maximum of 10 students in each of the 3 case problems. So first-come, first-served, you need to tell me which one you would like to be in. The next thing that I'm going to have you do is for whatever your first choice is, let's say, for instance, you told me your first choice is cost is no object, your second choice is classic reunion. Now, you don't know which one you have been assigned to, but I want you to take your first choice, cost is no object, and I want you to list the entities that you can identify within that system. Just come up with as many entities as you can identify within the scope of your first choice. And then for each of those entities, I want you to identify the attributes for each entity. And remember, attributes are things that we want to know about it and things that it should be able to do. So to the best of your ability, identify as many attributes for each of the entities. And then finally, I want you to define the relationships that you can identify between the different entities. Remember, every entity does not have to have a relationship with every other entity, but every entity must have at least one relationship, otherwise it's probably not needed. So that is your homework assignment for this week. You're going to be submitting an introduction, and you're also going to be selecting your case problem and then providing me with a list of the entities, attributes, and relationships. So if you want to submit your selection first, then you can just resubmit this assignment once you've had a chance to sit down and define the entities, attributes, and relationships. And let me know if you have any questions. You can send me an email in Canvas. Have an excellent weekend, and barring any unforeseen medical emergencies, I will see you in class on Tuesday.